So this unit is on sequence, and we try to link the beginning of every unit to something that the students are familiar with outside of the classroom, inside their real world. So sequence can, the example here, the pictures at the bottom, first, many people take a shower right when they wake up, and then next they brush their teeth, and then they get dressed and they eat right before they head out the door to work or to school. And then we can ask the students, what other sequences do they experience in their everyday life? Can you throw something out? What will your kids say?
Maybe their school day, like their schedule, if they have a certain, subject always the first time, or they have PE, that might be a sequence that they'll be familiar with their schedule
Right. And
during
teachers
the
are so
school
good
day.
at many times putting that up on the board and letting them know. Yeah. There's a sequence to turning on a video game, right? They have to sit there, make sure it's plugged in, push the button, they have to wait, and then they have to sign in, and then they have to choose their game. So that's a sequence they might be happy to talk about. Great. And then this discussion, why it's important to do things in sequence. Sometimes we can be flexible and we can change things around, but what can you communicate to your students why sequence is important and that there is a productive, good, efficient way to do things? What would you say to that? How would you explain that to your kids? Any ideas? I mean, we could talk in as far as cognitively, we wouldn't use that word with them, but we have to learn how to add before we learn to multiply, right? It's as far as understanding in class. We should take a shower before we put on our clothes because that just makes sense. It doesn't make sense otherwise. Sometimes, if in preparing a meal, you can't eat before things are done. So, if you can think of examples that will be helpful to them, that'd be great. So in their workbooks on page 11, they have this picture and the definition here. And if I were playing the slideshow, the yellow words would not have been there, and we'd have to think about a sequence is a set of something that follow one another in order. And so you can give them a couple minutes to write this into their books to help them remember that definition. And then we talk about what an algorithm is. But an algorithm is it's a special sequence. It's a list of steps to finish a task. So the sequence might be right here, but the algorithm is to start something and then actually to accomplish something. That's an algorithm. And the third related word is a program. So the sequence is just the order of events. Something's done in order. An algorithm actually completes a task, and then a program is the algorithm, but it is written in a language that a computer can understand. So that is the difference between a program and an algorithm. Okay, so the algorithm is the steps to complete a task. The program is those steps written in a way that a computer can understand. And then we want to try to help the students connect these things and remember them. Some students are visual learners, so maybe they'll remember the symbols. The sequence is just first, next, last, the algorithm, and then the program. So they can, yeah, you can push the button and you can have the students say, what's the first one? And maybe they'll say program and then sequence and algorithm. So those are introducing the three concepts we're looking at in this unit 2. And now you're going to lead them through an unplugged activity. So remember, an unplugged is something that the students do not in front of their computers per se, although there is a virtual version of this. The students don't need their computers if they're in person, and we're emphasizing the importance of first sequence, but also when you're giving computer instructions, they have to be very detailed, and the computer listens to exactly what you say. So sometimes when we give instructions, we leave something out because as humans, we can infer. Computers don't infer. So for this task, this is the desired outcome, this house. And these are the instructions. If you had a lot of time, it's kind of fun to take away the picture and have the kids actually draw it. But to fit in the 50-minute time limit of our our lesson, we decided just to have you analyze it. Read the instructions and then figure out which instructions don't work and which ones are incorrect. Find out what instructions are not correct and the computer wouldn't produce what we want to with these written instructions. Okay. This is also a little bit of debugging, and not a little bit, this is also debugging.
You also have a few optional unplugged activities for algorithms. In this activity, you can either do this as a full class or as an individual activity. The students have to write the algorithm that will produce the image of the frog face. Remind students that they have to be very detailed in their instructions because, as we know, computers cannot assume things that humans know. They can only follow the detailed instructions given to them by a human. We have another fun unplugged algorithm activity that students can do in pairs. There are two images in their workbooks, one on page 15 and the other on page 26. In pairs, the students can each choose one of these images and write up the algorithm instructions to draw the image. They then exchange instructions and try to draw each other's image. Once they draw the image, they exchange it back with the coder or author of the algorithm, who checks the image and identifies any errors in the algorithm. This is called debugging. It's a good way for students to understand that the first time that you write an algorithm, it may not be correct and may need some adjustments to make sure the outcome is what was expected. When students finish the unplugged activity, we have an optional turn and talk question for your students to talk about with a partner. Ask your partner something challenging that he or she likes to do and would like to be better at. Finally, we have a memorable role model, Margaret Z. Dominguez, who is an optical engineer. Have your students watch the video to find out what an optical engineer does and a little bit of her story. After the video, we have some statements for your students to review and identify which of the statements are true based on what they heard in the video. We also have two discussion questions that you can use as a full class discussion or as a journaling opportunity. The first question is the same as the turn and talk question. What is something challenging that you like to do and you would like to be better at? This is an opportunity for your students to volunteer their ideas or add their ideas to their journal. The second question is, who is someone in your life that can encourage you to try new things, just like the speaker at the conference encouraged Margaret to apply for an internship at NASA? Remember, these memorable role models are optional activities if you have time, but are very valuable to allow students to think about how computer science is used in different areas in the world and by different people. It opens your students' minds to explore opportunities that they may not have been aware of.